Welcome to Ask and Learn.
Hello everyone, so today we're at a linear momentum problem. So the problem we're doing today says that a 7,700 kilogram boxcar traveling at 18 meters per second strikes a second car. Now the two stick together and move off with a speed of 5 meters per second, and we're looking for the mass of the second car. So let's start off by defining what momentum is. Now conceptually to me, I think momentum is the movement of a mass. And so basically, we can represent this with a formula, very simple formula. So momentum can be represented by P, and then it is equal to mv, m being mass and v being the velocity. So let's note that there is a clear direct proportional relationship between momentum and mass and momentum and velocity. So what does this mean, right? So this means that if mass increases, momentum also increases. Now, this makes sense because if you have a very small truck, right, and if it hits you, it won't hurt as much as a extremely big truck that hits you. Now, if velocity increases, momentum also increases. Now, why is this? Okay, now imagine this. If a very slow truck hits you compared to a bullet, right? Despite the bullet being extremely small, the momentum is really big. Why? Because it's moving at an extremely fast speed. So knowing this, we can get back to our problem. In order to do this problem, we need to draw it out. So we have one boxcar and 7,700 kilograms. 7,700 kilograms, and we know that it has a velocity. Okay, and this velocity is 18 meters per second. 18 meters per second. And it's a boxcar, so it obviously has wheels, right? And it is going to collide with a second car. Now we don't know what the mass of this second car is, and we're assuming that this second car is at rest because the problem does not give us any details. So let's keep that in mind. M is equal to x, right? And v is equal to 0 meters per second. This is only the initial state. This is initial state, right? Because we know that there's a second part of the problem. We know that this is the first moment, and in the second moment, something else happens. The first boxcar appears to have been stuck onto the second boxcar, and now it moves at a velocity of 5 meters per second. So 5 meters per second. This is really interesting because this is actually a conservation of momentum problem. Now, this principle says that the sum of the initial momentums is equal to the sum of the final momentums. So this is where the problem really develops. We can represent this principle with the sum of P initial is equal to the sum of P final. Always write out these steps so that you can trace back your mistakes, right? So now let's look at what the initial momentums are. And we can trace that back with the diagram we used. So here we know that P initial 1 would be the first boxcar. And we know that P initial 2 is the second boxcar. Now the final state would be P of 1 plus 2 because they're stuck together. Final. And we know, according to the equation we have here, that P is equal to mv. So let's break down P and substitute it, right? So P initial 1, what is that equal to? It's equal to the mass of the first boxcar multiplied by the velocity of the first boxcar. And you do not need to do P initial 2. Why? Because the velocity is 0 meters per second. And we know that 0 multiplied by any mass will still be 0. so that does nothing. So let's focus on the final. And the final is clearly the mass of the first boxcar and the mass of the second boxcar multiplied by the velocity of both these boxcars. This is smooth sailing from here. Why? Because you can simply substitute numbers and solve. So let's do that together. So what is the mass of the first boxcar? 7,700 kilograms. Easy enough. Velocity of the first boxcar, where can we find this? In our diagram. And that's 18 meters per second. 18 meters per second. Now, what is this equal to? Well, this is equal to the sum of, again, the first boxcar. This is a 7. Why does it look like a 2? I don't know. 7,700 kilograms plus an X amount of mass for the second boxcar multiplied by the velocity of the two boxcars when they move together. And that's 5 meters per second. Very simple stuff. From here, all you do is some basic algebra, right? I'm not going to do that for you guys because I trust that you guys can do simple math. So basically, right, you divide and then you subtract and you have your X value. Simple algebra, simple lesson, simple problem. Now this was linear momentum and the conservation of momentum principle. I hope you learned something. Thank you.